Astronomers have just uncovered a mysterious new world at the far edge of the solar system, and within hours, it began overturning one of the most debated ideas in modern astronomy, Planet 9. Spotted through Subaru's powerful wide-field survey, this tiny drifting speck turned out to be something far stranger than expected. In this video, we'll explore how scientists uncovered it, why its orbit defies every rulebook, and how this discovery could rewrite our entire picture of the solar system's formation. The story of Ammonite's discovery began with a barely visible point of light captured during routine deep sky surveys. At first glance, it looked like nothing more than random noise, a dim artifact that appears once and disappears forever. But astronomers noticed something subtle and consistent. Across multiple images, the faint speck shifted ever so slightly. That tiny drift was the first hint that this wasn't a background star or a camera glitch, but an object truly orbiting the sun. To test that possibility, researchers followed the meticulous process used for confirming the most distant solar system bodies. They began by calculating where the object should reappear months later if it were genuine. When telescopes pointed back to that predicted location, the same faint speck appeared, precisely where the calculations said it would be. This instantly transformed Ammonite from a suspicious into a confirmed solar system object following a measurable trajectory. With this extended timeline, astronomers could compute its orbit with remarkable precision. And that's when the shock emerged. The calculated orbit didn't resemble Kuiper belt objects, scattered bodies, or even the rare detached objects we already knew. Instead, it fell into a region that had appeared empty for decades, a gap scientists assumed simply lacked members. Ammonite became the first object to clearly fill that void, proving the region was never empty at all. What this discovery revealed wasn't just a new object, but a hidden structure in the solar system's farthest reaches. And this unexpected structure leads directly to the next mystery. Why does Ammonite move the way it does? Ammonite's true significance lies in its orbit, a path so unusual that it immediately sets this object apart from almost everything we've cataloged. Its closest approach to the Sun, roughly 70 astronomical units, places it far beyond Neptune's gravitational domain. That alone is rare. But the full extent of its orbit stretches several hundred astronomical units outward before returning, creating a sweeping, elongated loop that takes nearly 4,000 years to complete. This extreme orbit places Ammonite within the tiny family known as sednoids, an ultra-rare group of distant worlds with only 3 confirmed members before this discovery. Sednoids have puzzled astronomers for years because their orbits simply don't fit the traditional models of how the solar system evolved. They're too far from Neptune to be shaped by its gravity, too stable to be random leftovers, and too isolated to belong to any known category. But Ammonite does something unprecedented. It occupies the long-predicted but never-observed transition zone between ordinary Kuiper belt objects and the classical sednoids. For decades, this region appeared empty, as though something had prevented objects from forming or surviving there. Now we know the truth. The region wasn't empty. Our instruments simply weren't sensitive enough to detect objects this faint. Its physical nature adds another layer of intrigue. Based on its brightness and reflectivity, Ammonite is estimated to span between 200 and 400 kilometers in diameter, large enough that gravity may have shaped it into a rounded form. That makes it a potential dwarf planet, a tiny, icy world with its own geological identity. Even more fascinating is its reddish hue, a coloration produced by organic molecules altered by billions of years of cosmic radiation. Objects this distant are frozen time capsules, preserving chemical ingredients from the solar system's earliest days. Studying them is like opening a vault filled with material untouched since the planets first formed. In every way, orbit, size, age, chemistry, Ammonite stands out. It fills a missing chapter in our planetary architecture and hints that many more worlds like it may be hiding in the cold darkness. But the greatest impact comes from what it says about the controversial idea of Planet 9. For nearly a decade, one theory has dominated discussions about the solar system's frontier, the existence of a massive, unseen world known as Planet 9. The strongest argument supporting it was the strange clustering of several distant objects whose orbits all pointed in similar directions. That alignment looked artificial, as if a hidden giant planet were shepherding their motions from the shadows. But Ammonite breaks that pattern entirely. Its orbit simply does not line up with the supposed alignment that Planet 9 requires. Instead, it takes its own direction, diverging from the very objects that form the backbone of the Planet 9 hypothesis. While a single contradiction isn't enough to dismiss the idea, each new distant object that defies the pattern weakens its foundation. If many more discoveries resemble Ammonite, the Planet 9 theory may collapse under its own weight. This pushes scientists toward deeper, more ancient explanations for why the solar system's edge looks the way it does. One possibility is that the sun formed in a crowded stellar nursery, where close-passing stars tugged on the outer disk in the solar system's earliest years. Another possibility is that the solar system once hosted an extra-giant planet that was eventually ejected, leaving behind distorted orbits like frozen signatures of a violent past. There is even the possibility that the Milky Way itself, through slow, steady gravitational tides, gradually sculpted these distant objects over billions of years. Simulations performed by researchers suggest that Ammonite's orbit is ancient and remarkably stable. This means whatever shaped it likely occurred more than 4 billion years ago, during the solar system's turbulent formation. Ammonite is not responding to forces acting today. It is preserving a fossil record of forces that acted long before Earth even existed. And this discovery may be only the beginning. If Ammonite sits in a region once believed empty, then dozens or even hundreds of similar objects may be waiting to be found. Upcoming deep sky surveys and next-generation telescopes will reveal fainter, slower, more distant worlds than ever before. Each one will refine our understanding of planetary formation, and maybe answer whether Planet 9 is real or whether the truth is far stranger. Ammonite has transformed from a faint speck into one of the most important discoveries of modern planetary science. Its orbit challenges long-standing assumptions, its chemistry preserves ancient materials, and its position reveals a hidden structure at the solar system's edge. And if this tiny world is the first to appear, imagine what else is still waiting out there. If you enjoyed this video, make sure to like, share, and subscribe, and let me know your thoughts in the comments below. Your support means the world and keeps our journey going.